Right, the title of this code signal challenge is ArrayMaxConsecutiveSum2, and it's a medium uh, problem, and then I'll be solving it in Java. Okay, so the description says given an array of integers, find the maximum possible sum you can get from one of its contiguous subarrays. The subarray from which this sum comes must contain at least one element. So we have an example there. So looking at this 1D array, you have to find the maximum sum you can get. If you try to sum up all these, it would not give us the maximum sum. I believe this would be 0. As we sum up this whole number, it will give us 0. Meanwhile, we have 2 plus 5, which can give us 7, which will form the maximum sum. So, and the key to this problem is that the numbers from which we are getting the maximum sum from must be consecutive numbers. So 2 and 5 are consecutive, but 5 and 6 are not consecutive. It means they don't follow each other. And another key is that it can just be one element, which means it can just be 6. Okay. But in this case, 6 is not the maximum because we have 2 plus 5, which is 7. All right. So one approach, the brute force, is that we keep summing up and then comparing the maximum, comparing the sum we get at every index to find which one is the maximum. So we sum up this and then we compare to the summation of 5 to the addition of minus 11 and then continue like that and figure out, okay, what's the maximum at the end of the day. Okay, but that would not be effective, and I will show you why that won't be effective in a bit. Okay, let me just go to that right away and do the brute force approach. So I'm going to declare my output and I'm going to make it integer, that's minimum value. Okay. And then I'm going to return that. All right, so I'm going to go for the first for loop. Okay, so is less than the length of the array. Okay, and then I'm going to now assign value here as my sum. Okay, let me first do that. Yes, because it can actually be for a single element. Okay, and then I'm going to compare that. Now I'm going to say max sum equals, let me use math.max to compare max sum. Okay, and sum. So if that single element is higher than every other summation we've had initially, you should just make that the maximum sum. And then I'm going to declare for the inner loop now and say, so, okay, equals b equals to a plus 1. Okay, and then b less than. Okay, so we look to the end of the same array. Okay, right, and then I'll compare again. So I'll now say sum. Okay, I'll just say sum equals b. Yep, and then compare whatever I get in there. Should have just copied to that, but let me type and say, okay, sum and max sum. Yep, Yes, I guess this will do it. So let me run this, and so that I'll show you. I believe this should just integer.min. Oh, sorry. Uh, okay, so it passed the sample test, but when I submit it, so let me submit and let's see. Okay, it's telling me challenge is not active. Okay, so it's saying incorrect. So I have 11 tests that's been done. Okay, it was passed 10 of those, and then only one. And that one is that said execution time limit exceeded, because this is actually O of n square, which is not good at all. So we should find a way to actually reduce the time complexity of this particular solution. So what's our input? So we just try to consider what we're given now. We're given an 1D array. Okay, in order to figure out what a better solution will be. Okay, and our output is an integer. Okay, so kind of a strategy. What strategy, sorry, would be the best strategy? Yeah, okay, now if you look at this, we are summing up, trying to figure out what the maximum is. Okay, looking through each of the arrays. Is there a way we can figure out what the maximum is at each of these index? Okay, and one approach to demonstrate you can use is dynamic programming. And this typing thing is okay. So dynamic programming means I can actually store the maximum sum at each of these index and then compare it with the next one and with the next one, and then storing the maximum at each index, and then whatever maximum I get at the end of the loop becomes my maximum sum, and then I just return that. So the process for that is store maximum sum at each index. Okay, good. So with that, it means I don't need this second loop. Okay, this second loop, and then I can put my sum out there. Okay, and then okay, because I already know that maximum I can get at the first index is the first element, so I can just call that the maximum sum, and then start my comparison from there. So now the first thing is to determine sum that I'll be making use of. So I'll say sum equals math dot max. Okay, I'll compare the current sum, impute, okay, at the current index. Okay, current sum plus the impute, sorry, at the current index. Okay. Okay, that'll give me the current sum, and then I'll compare with the maximum sum, and then I'll return this. So at each index, okay, I'll be having what the maximum sum is. Okay, so at index 1, we know the maximum sum is -2, so I don't need to do so much that, but I'll compare if adding 2 plus -2, which is what is happening here, is greater than if it's just 2. But for this now, the sum will be 2. All right, and then I'll compare that with whatever the maximum sum from previous operation was, and then store that as my maximum sum. So let me see. if this is actually correct. Sorry. There's an error somewhere. Some marks sorry. Sorry, I'm supposed to start from 1. Since I already figured out what the maximum sum is at 0. And it passes like the other approach passed. So I'll just submit now. All right, so it's correct, which means our time complexity is actually good because it's running at O of n here. So we are running at O of n here, complexity. So it's a very good solution. So this is my solution for this particular problem. So I'll be solving more challenge or problem from CodeSignal. I might do lead code and the likes. And I might still, so I will also be dropping tutorials on Java as well. So let me know what you guys think. I hope I'm able to explain it very well. Thank you. Also subscribe to my channel, share, let others know about it. Let me know whatever you feel I should drop later as well. So thank you so much.